Hi everyone, let's solve today's LeetCode challenge, which is arithmetic subarray. So in this problem, we are given with an array and two more array L and R of size m. And let's say arrays of size m. So these two array represent the queries which is having the L is having the starting position of every subarray and R is going to have the ending position of every subarray. And what we have to return is for each subarray formed from L and R, we have to return whether that subarray is arithmetic sequence or not. Okay, let's have a look on this example. Nums. We are given a nums array, an L array, R array. These are the left index and these are the right index for each subarray. So let's say for first subarray is 0 to 2. From 0 to 2. This is our first subarray. 4, 6, 5. And we have to return is this subarray can be rearranged and we have to return whether it is a arithmetic sequence or not. So we need to check whether it is a arithmetic sequence or not. Before that, what we can do is we can rearrange that. So what is arithmetic sequence? Arithmetic sequence is an array in which all the consecutive elements are having same difference. So let's say in this case, 1 and 3 is having 2, 3 and 5 is having 2, 5 and 7 is having 2, this is also having 2. So the same difference is there between each consecutive pair. So it is arithmetic sequence, right? This is also arithmetic sequence, the difference is 0. So let's say in this case, from 1 to 1, the difference is 0. From 1 to 2, difference is 1. This is a mismatch in the difference. So it is not a arithmetic sequence. So for any for any array to be a arithmetic sequence, what we can realize that it should be in the sorted manner. Okay, so what we can do is in the starting we can sort this array and then we can check whether each consecutive pair is having equal difference or not. Right? So what we will do is if we sort this array 4, 5, 6, now we can see the difference. From 4 to 5 it is 1, from 5 to 6 it is 1. So yeah, it is an arithmetic sequence. So we are going to add true in our answer list. So now what we have to do is we have to perform this step for each of the query. The second query is from 0 to 3. This is 0, this is 3, 4, 6, 5, 9. So if we sort this array, it will be like 4, 5, 6, 9. Now let's check. 4 to 5, 5 to 6, 6 to 9. It is 1, it is 1, it is 3. So no, this is not a arithmetic sequence because the difference between each consecutive pair is not same. So now we are going to add false to our list, and now from 2 to 5, this is 2, this is 5. So subarray is 5, 9, 3, 7. After sorting, it will become 3, 5, 7, 9. 3 to 5, 5 to 7, 7 to 9. The difference is same between all, so it is true. So true, we are going to add in our answer. So this list will behave as our answer. This we have to return from our program. So now what I did is we extracted the subarray from each query and then we sorted the subarray and then checked whether it is arithmetic sequence. Let's try to understand the time complexity for this problem. Let's say we are having n length subarray. So to sort n length subarray, it would be n log n. Okay, and total we have m queries. So it would be m into n log n. Now there is one more approach to solve this problem. Let's say for each subarray, let's try to check for the first query, which is 0 to 2. This is 4, 6, 5. Earlier we were sorting this array 4, 5, 6, which was n log n time. Okay. So now, if it is a arithmetic sequence, so what would be the case? We can check for the minimum element and we can check for the maximum element. So from minimum to maximum it will go, and then how many times the number of elements in this array. So let's say in this case we are having three elements. So the first one should be minimum because it is an arithmetic sequence, and the last one should be the largest one, and the remaining one will be in the sorted form. So here we have three elements. So from the minimum to the next one to the largest one. Okay, in this case, what we can figure out is we can iterate over this array, check for the minimum and check for the maximum element. And what we can do is we can divide that with the length minus 1. If n is the length for this subarray, it would be n minus 1, because we want, because for n elements, here it was 3 elements. For 3 elements, we wanted 2 differences, and for n element we will need n minus 1 differences. So what we can do is the difference between what will the difference between these two? So maximum minus minimum, so it is the total difference, and we have to divide this difference in two form. So it will be divided by n minus 1. So for n element also, it is like the minimum element, the maximum element, the difference between that element is the total difference from first index to last index, and we have to like figure out these differences. So to divide the bigger difference to this, we can just divide that to the number of differences we need. In this case, we required two differences, so I divided it with 2, which is length minus 1 and 3 minus 1. Okay, let's check for the second subarray, which is 0 to 3. From 0 to 3, it is 4, 6, 5, 9. 4, 6, 5, 9. So firstly we have to convert it, check whether it is an arithmetic sequence or not. We will calculate the minimum element. We will calculate the maximum element. Minimum element is 4, maximum element is 9. So it would be like this: 4 and 9 and other elements in between. How many elements will be there in between 4 and 9? Uh, Two elements, because 2 we have already used. Let's say this is first element, this is second. And how many differences? We require 1, 2, 3, which is 4 minus 1. So 3 differences we need, which is equal to n minus 1. And what is the total difference between minimum to maximum? This is maximum minus minimum. So if we check the maximum minus minimum divided by n minus 1, this would be the difference between each element if it is an arithmetic sequence. So we will start with the first element. We will check whether first element plus difference, let's say nums of I plus difference, exist in this array or not. Okay, so what we can do is we can maintain a hash set. 4659 will maintain a hash set for this, and from starting to end, I will from not from starting, from the minimum element. Let's say which is the one from the 4. From the minimum element, if I keep on adding the difference, I will just reach till the maximum element. So I will start from 4 and I will add minimum difference to that, and I will see whether it is present in our set or not. If it is present in our set, then it is an arithmetic sequence so far. If all the elements are checked and we have reached the maximum element, it means from 4 to 9, all arithmetic sequence elements are present with difference diff. So it means this subarray is a valid arithmetic sequence. We just traverse the subarray. So let's say we are having n sub m queries, and let's say subarray can be of length n at max. So this is going to be O of m into n, which is less than the m into n log n, which we did in the previous approach. So this is the better approach. Firstly, we will take a Boolean array to store our answer. M is the length of our each query. So we have m queries. So now we are going to iterate over each query and we will prepare our subarray. So subarray of length, which is equal to li to ri minus li plus 1, because we have to include ri as well as li. Going from li to ri, and we will store that element in our ARR array. Now what we have to do is we have to check for this subarray whether it is arithmetic sequence or not, and we will capture the result in our answer list, and then we can return the answer list. So now we just have to implement this check function to check whether our subarray is arithmetic sequence or not. Getting my subarray as an input, I'm returning boolean from this sub function. Minimum element, maximum element. As we discussed while discussing the problem, we just have to check for minimum element and the maximum element for the current subarray. So because the arithmetic sequence is going to be start from minimum element to maximum element, and we will also maintain our set, and we will iterate over our subarray, and we will add all the elements in the set. So when we are preparing our arithmetic sequence from minimum to maximum using difference, then we will see whether that element already present on our set or not. Iterating over array to capture minimum and the maximum. We also need to capture every element from array in our set. Now what we have to do is we will calculate the difference using minimum and the maximum element. We already know the length of the array, so the maximum difference we can get from first element to last element is max minus min. And how do we have to divide it to the to the differences we need? Let's say for an array of four elements, we need three differences at least. So 4 minus 1, that would be array dot length minus 1. So uh, our current element should be our while the current is not equal to max, or maybe while the current is less than or equal to max, we will check the current value whether it is present in our set or not. If it is present in our set, then it is fine. Otherwise, we just have to return false. It's not an arithmetic sequence. Now what we can return is we just have to return true because we have iterated over all the elements. Okay, now let's try to submit our sample test cases. All the sample test cases it has passed, trying to submit the problem. Oh, we got the TLE, time limit exceeded. Let's try to have a look on our implementation. Here, we need to see whether this difference is a valid integer or not. So if the max minus minimum, if the total difference is divisible by the length or by the number of differences we need, if that is an integer, or even in that only in that case we can say that it is an arithmetic sequence. If that is not an integer value, let's say we got a floating value, in that case we cannot say that it is an arithmetic sequence, so we can directly return false from there. Now let's try to submit again. It is submitted successfully. Hope you understood the problem. Thank you guys.